Welcome second year students. Today we shall discuss about flip flops. So flip 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 flops FLOPS. Flip means on, flop means off. So today we are discussing about off and on circuit. That is, the circuit can be made off for some time and the circuit can be made off for some time. When the circuit is on, the circuit stores the information. When the circuit is off, the circuit is restore the information. That is, the circuit is reset. Therefore, we can set the circuit or we can reset the circuit to store the information or to de-store the information. So, any circuit which is used to store the information or restore the information, it is called flip-flops, on and off circuits. Usually, flip-flop is nothing but a memory unit used to store the information. Now today we shall discuss about these flip-flops. Today we shall discuss about flip-flops constructed using NAND gates. Flip-flops constructed using NAND gates. But in the last class we have discussed about the construction and working of NAND gate. Before studying about the flip-flop, let us study the working of NAND gate. And we have already studied the working of NAND gate and its constructions using an ordinary bipolar transistors and CMOS, complementary metal oxide semiconducting field effect transistor. Since CMOS performs very good compared to an ordinary transistor, usually the flip-flops or usually the NAND gates are always constructed using CMOS gates because of its good performance. Now, what is NAND gate? The symbol of NAND gate is this. This is the symbol of NAND gate. If A and B are the two inputs of the NAND gate, the output Y is equal to A into B bar. We have already studied. Therefore, the output depends upon the two inputs with a formula A into B bar. Bar means complementary. So when A equals 0, B equals 0, Y equals 0 into 0, 0, complementary is 1. Therefore, when A and B and output, I will write this is the NAND gate output. When input A is 0, input B is 0, Y is equal to A into B bar, 0 into 0, 0, complementary 1, Y is 1. When input A is 0, input B is 1, again 0 into 1, 0, complementary 1, output is 1. If input is 1, output is B. If the input A is 1, input B is 0, again 1 into 0 is 0, complementary 1, output is 1. If both inputs A and B are 1 and 1, what is the output? 1 into 1, 1, complementary 0. So this is the output of the NAND gate. See, output of the NAND gate is 1 whenever the input is 0. If any one of the input is 0, here A is 0, B is also 0, here A is 0 and B is 0. Therefore, if any one of the input is 0, output is 1. That is NAND gate. Even if the NAND gate has number of inputs, all among the number of inputs, if any one input is 0, 0 multiplied by all 1 is 0, complementary is 1, therefore output is 1. So to discuss about the flip-flops, you should know that if any one of the input of the NAND gate is 0, output is 1. Remember this for the study of the flip-flop. Now, Flip-flop, what is flip-flop? Flip-flop is nothing but a simple electronic circuit constructed using NAND gates or NOR gates. Both NAND and NOR gates are universal gates. Now we shall study the flip-flop constructed using NAND gate only. You can also construct using NOR gate, but we will study the construction of flip-flop using NAND gate only. So a flip-flop is an electronic circuit which either offs or ons. That means a flip-flop is an electronic circuit whether it flips or whether it flops. When it flips, the output is 1. When it flops, the output is 0. This simply means when the output is 1, it stores the information. When the output is 0, it destores the information. That means a flip-flop can be used as a memory element, and this memory element is used to store the information. If the output of the flip-flop is 1, we say that the information is stored. If the output of the flip-flop is 0, we say that the information is destored. So, first we shall discuss about SR flip-flop. Now let us discuss about SR flip-flop. Flip-flop is an electronic circuit which is used to store the information. Therefore, it acts as a memory element. Here we are studying SR flip-flop. S means set, R means reset. Set and reset flip-flop. That is, the flip-flop or electronic circuit can be either set to store the information or it can be reset back to destore the information. Therefore, a flip-flop usually has two inputs. One input is called set, another input is called reset, and two outputs. One output is the complementary of the other output. Therefore, if one output is 0, the other output is 1. If the one output is 1, the other output is 0, because the flip-flop has two inputs and two outputs. The two outputs are complementary to each other. If one of the output is 0, the other output should be 1, because they are complementary to each other. Now, this is a simple circuit of SR flip-flop constructed using 4 NAND gates. The first NAND gate, the two inputs of the first NAND gate is shorted and connected to a single input A. And the two inputs of the second NAND gate are shorted and connected to a single input B. A and B are the two inputs. Now, Qn and Qn bar are the two outputs. We call these outputs Qn and Qn bar as previous output. I will explain what is meant by previous state output. This is Qn and Qn bar is called previous state output. Qn1 plus Qn1 plus bar are called next state output, or simply we call it as final output. This circuit consisting within this block diagram is called latch, L-A-T-C-H, latch. The circuit within the inner box is called latch. That means the circuit in which output is fed back to the input is called latch. See, in this circuit, output of this NAND gate is fed back to the input of this gate, and output of this NAND gate, that is Qn bar, is fed back to the input of the above gate. So the output of one is fed back to the input of other, and this circuit is called latch circuit. Since the output Qn bar is fed back to this input of this, the input of this is now, see, this is Qn bar. Therefore, input of this is Qn bar. Here the output from this, that is Qn, is taken here and applied to the input of this. Therefore, this input is Qn. This input of this gate is Qn bar. The input for this NAND gate is Qn. It is fed back like this. Now, we shall study the different outputs for different input conditions. First, when no inputs are applied. So, when no inputs are applied means no power supplies are connected. You need a power supply for the point A, you need a power supply for the point B, but when the power supplies are not connected, when the inputs A and B are not considered, when this circuit is switched on, since the outputs are opposite to each other, one is Qn, another is Qn bar. If one output goes 0, another output goes 1. For example, if Qn goes 0, Qn bar goes to 1. This 0, 1 outputs are called previous state output because no inputs are applied. Therefore, previous state outputs are nothing but the outputs of the flip-flop when no inputs are applied. ಯಾವುದೇ ಇನ್ಪುಟ್ನ ಅಪ್ಲೈ ಮಾಡದೇ ಇದ್ದಾಗಲೂ ಸಹ ಇರೋ ಔಟ್ಪುಟ್ಗೆ ಪ್ರೀವಿಯಸ್ ಸ್ಟೇಟ್ ಔಟ್ಪುಟ್ ಅಂತ ಕರಿತೀವಿ. ಅದು ಯೂಶಲಿ ಒಂದು ಔಟ್ಪುಟ್ 0 ಇದ್ದರೆ ಇನ್ನೊಂದು ಔಟ್ಪುಟ್ಟು 1 ಇರುತ್ತೆ. If one output is 0, another output is 1 because another output is complementary of the first one. Now, I will apply two inputs A and B here. What are the possible inputs? If you have two inputs A and B, the possible inputs are 0, 0, 0, 1, 1, 0 and 1, 1. Now we will study the output for all these four inputs. First, when no inputs are applied, the outputs of the flip-flops are Qn and Qn bar. This is called previous state output. When the inputs are applied, A equals 0, B equals 0, A equals 0, B equals 1, A equals 1, B equals 0, both A equals 1, B equals 1, all types of four inputs. When the inputs are applied, the outputs got from the circuit are called final output or next state output. It is represented by Qn plus 1, Qn plus 1 bar. One output is Qn plus 1 and another output is Qn plus 1 bar. So the difference between previous state and next state inputs are, the previous state outputs are the outputs of the flip-flop when no inputs are applied. And the outputs of the flip-flops are said to be next state or final state when the inputs are applied. First input condition. In the first case, when A is equal to 0, B is equal to 0. What is the output? Qn plus 1. When A equals 0, B equals 0. Since one of the input of this NAND gate is 0, output is 1. One of the input B is also 0, the output is 1. Now, Qn is the input. 1 is the input for this gate. 1 into Qn is Qn. Therefore, output of this Qn plus 1 is Qn itself. Qn plus 1 is equal to 1 into Qn. This is Qn bar, okay? 1 into Qn bar and complementary. because output of the NAND gate is complementary of the two input. One is the input, Qn bar is the another input. 1 into Qn bar complementary is the output of this NAND gate. Therefore, output of the NAND gate is Qn plus 1 is equal to 1 into Qn bar of bar, which is equal to 1 into Qn bar is Qn bar itself, whole to the power of bar get cancelled, which is equal to Qn. If Qn plus 1 is Qn, the another output, that is Qn plus 1 bar, should be complementary of this, that is Qn bar. Previously, it was Qn and Qn bar. When A equals 0, B is equal 0 are applied, again the final outputs, that is Qn plus 1 and Qn plus 1 bar are Qn and Qn bar. Thus, even when the inputs A equals 0, B equals 0 are applied, the output remains in the previous state itself. Therefore, in this condition, when A equals 0, B equals 0, the final output remains in the previous state. This output is Qn, this output is Qn bar. Once again I will explain. See this circuit. When A equals 0, B equals 0. When A equals 0, complementary is 1. When B equals 0, complementary is 1. So one of the input of this NAND gate is 1. Another input is taken from the output of this one. Therefore, this output acts as an input for this one. That is Qn bar. 1 into Qn bar to the bar is the output of this NAND gate. So when A equals 0, B equals 0, Qn plus 1 is equal to 1 into Qn bar of bar, which is equal to Qn double bar equals Qn. Therefore, one of the output Qn plus 1 is equal to Qn. Then the other output Qn plus 1 bar is complementary of this, that is Qn bar. So when A and B are not applied, the previous output are Qn and Qn bar. When A equals 0, B equals 0 are applied, the final outputs are again Qn and Qn bar. That means the final outputs remains in the previous state when the two inputs of the flip-flops are 0 and 0. I will consider the case 2. That is when A is equal to 0, when A is equal to 1 or when A equals 0, B equals 0. Let us consider the case 2. When A equals 0, B equals 0. When A equals 0, B equals 0 aitala. Next, when A equals 0, B equals 1. Let us consider the next condition. So, A equals 0, B equals 0, first condition. A equals 0, B equals 1, second condition. Then what are the outputs? When A equals 0, complementary is 1. And when B is equal to 1, the complementary is 0. Now this Qn bar is applied here. 1 into Qn bar is Qn bar. Output of this NAND gate is complementary of Qn bar. Therefore, output of Qn plus 1, output of Qn plus 1 is the complementary of the inputs 1 into Qn bar, which is equal to 1 into Qn bar is Qn bar to the bar, which is equal to Qn itself. And therefore, Qn plus 1 bar is equal to, that is output of this Qn plus 1 bar. How do you get this output? This Qn is applied here. 1 is the input of this. Since 1 is the input, output of the NAND gate is 0. 1 complement is 0. One of the input is 0 and one of the input is Qn. 0 into Qn is 0. Therefore, complement of that is 1. Qn bar goes to 1. Therefore, Qn plus 1 is given by 0 into Qn complementary, which is equal to 0 into anything is 0 complementary. 0 complementary is 1. You see, Qn plus bar 1 is 1. Then what should be Qn plus, when Qn plus 1 bar becomes 1, what is Qn plus 1? It should be 0. because these two are complementary. Therefore, this Qn should indicate 0. Therefore, when A equals 0, B equals 1, final output is 0 and 1. When A equals 0, B equals 1, final outputs are 0 and 1. Let us consider the third case. When A equals 1, B equals 0. Let us see what happens. See this circuit. When A equals 0, when A equals 1, B equals 0. When A equals 1, B equals 0. When A equals 1, the output of this NAND gate complementary, it goes to 0. Since the input is 0, the output of this NAND gate goes to 1. Here 0 and Qn bar are the two inputs. Therefore, the output Qn plus 1, the output Qn plus 1 is equal to NAND of these two inputs, that is 0 into Qn bar, which is 0 itself. Complementary of that is 1. Therefore, this is equal to 0 into Qn bar of complementary, which is equal to Qn bar complementary into 0 is 0 itself of complementary, which is equal to 1. Then what is the other output Qn plus 1 bar? Qn plus 1 bar now becomes 0 is the input, complementary, 1 is the output. This is taken as the input. Therefore, input of this is 1 and Qn. 1 and Qn are the inputs. 1 into Qn is Qn. Output of this is complementary, Qn bar. Therefore, Qn plus 1 is 1 into Qn. Here, the output of Qn plus 1 is what? The output is Qn plus 1 output is 1. Therefore, the Qn plus 1 output is 1. This 1 is taken as the input. This 1 is the another input. 1 into 1, 1. Complementary, 0. Therefore, output Qn plus 1 bar is 0. I will represent like Qn plus 1 bar is 1 into 1 of complementary, which is equal to 1 complementary is equal to 0. Therefore, when A equals 1, B equals 0, Qn plus 1 is 1, Qn plus 1 bar another is 0. So, right here, when A equals 1, B equals 0, this is 1 and this is 0. Now, the last condition, that when both inputs A and B are 1. Fourth condition, when A is also equal to 1, B is also equal to 1. Let us see what happens. See this circuit. When A equals 1, B is also equal to 1. The complementary of this NAND gate, output is complementary of this, is 0. Since this is 1, the complementary of this, the output is 0. So, one of the input of this NAND gate is 0. Therefore, output is 1. One of the input of this is 0. Output is 1. Both the outputs are 1 and 1. It is not possible because one input is the complementary of the other input. One output is complementary of the other output. If one is 0, other should be 1. If this is 0, this should be 1. Or if this is 1, this should be 0. Both 1, 1 cannot be possible because this is Qn plus 1, this is Qn plus 1 bar. Therefore, it is illegal, indeterminate, not defined. Therefore, 1 and 1, when the inputs are 1 and 1, the outputs are also 1 and 1. It is not definable. Therefore, from this tabular column, we can say that when A equals 0, B equals 0, the output remains in the previous state. In any flip-flop, if output remains in the previous state, we call it as memory element. Okay? For any flip-flop, if the final output remains in the previous state inputs, previous state outputs, such element is called memory element. In the second case, when A equals 0, output is 0. Let us consider Qn plus 1 is output. When A equals 0, output is 0. That is, output is reset. 0 and there is no information. Output is reset. When A equals 1, output is also 1. That is, we say that output is set. The flip-flop is set. Therefore, we can call the inputs A and B as S and R, set and reset inputs. Now, when set input is 0, reset input is 0, it acts as a memory element. When set input is 0, reset input is 1, there is no output. That is, the circuit is reset. When set input is 1, reset input is 0, output is 1. That is, the circuit is set. When both 1 and 1 outputs are 1, 1, this is indeterminate or illegal. We call this as illegal or indeterminate. And this condition is not used. We use only these two conditions. If making S as 1, we set the circuit. If making R equals 1, we reset the circuit. Therefore, this type of flip-flop is called set and reset flip-flop, or simply SR flip-flop. So I will write, instead of A and B, now I will write S and R, set and reset flip-flop. So summary, a flip-flop is a memory element used to store the information. The flip-flop can be constructed either by NAND gates or NOR gate. Both are universal gates. This is a simple circuit of SR flip-flop. SR flip-flop has two inputs, set input and reset input. It has two outputs, Qn and Qn bar. These are previous inputs, Qn plus 1, Qn plus 1 bar. These are called final output. Final outputs are those outputs when the inputs are applied. The previous outputs are those outputs when no inputs are applied. In order to set the flip-flop, that means in order to store the information, the flip-flop has to be set. For this, the set pin S is made 1. In order to destore the information, in order to reset the circuit, the reset pin R is made 1. Only two conditions are used. During 0, 0, it remains as a element, memory element. 1, 0, the flip-flop is set. 0, 1, the flip-flop is reset. 1, 1 is not considered.